Hi, I'm Michelle from the Compliant and Accountable Systems group at Cambridge Computer Lab. Today, I will talk about my paper with Singh on the landscape and gaps in open source fairness toolkits, for which we were honored to win a Best Paper award this year. With rising concern around algorithmic unfairness, several open source toolkits have recently emerged. Fairness toolkits are pre-packaged code, often with a user interface, that takes a dataset and/or a pre-trained model as the input. The users specify which outcome and predictions they want to test for bias and against which sensitive feature. For example, I'd like to test whether there's a difference in false positive rates between men and women in my identity verification model. The outputs are the fairness test results and accompanying visualizations. Some toolkits offer the ability to debias, including pre-, in-, and post-processing methods. The intent is to inform the developers in assessing whether a model is fair so that this can in turn inform real-world decisions. We conducted a multi-stage study with the focus group interviews and surveys of industry practitioners on their views on the existing open-source fairness toolkits. Detailed methodology can be found in the full paper. These 6 open-source toolkits were identified through the focus group. We confirmed later with the survey that this landscape coverage was sufficiently representative. One of our contributions is this big table compiling the features of each toolkit. Their coverage of fairness metrics and model types varies, so this helps practitioners identify what's compatible with their model and desired metric. Our next contribution is the exploration of fairness challenges through the practitioner's views on these toolkits' gaps. We will cover the 5 highlighted themes. Please see the paper for the full gap analysis. The first gap is the limited accessibility of the toolkit search process. Almost all interviewees claim to use the first toolkit they find that meets their needs. This is problematic because of the diversity of toolkits' approaches to fairness. For example, Fairness 360 focuses on bias mitigation technique implementations. Audit AI implements what is known as the 4/5 rule and focuses on proving statistical significance of any disparity. FairLearn explicitly avoids the term bias and debiasing, unlike Fairness 360, defining fairness in terms of allocative and representative harms. Fairness toolkits reflect the perspective of the designer on what fairness means and how it should be assessed and mitigated. This raises the risk associated with the selection of one perspective over another without understanding the underlying differences. Another key gap is the steep learning curve to use the toolkit. Here are the system usability scale scores out of 100. They are all below 70, which is often the reference point for passable usability. Almost half of the interviewees needed to learn a lot of things before they could get going. For the focus group and the interview, practitioners with expertise in fairness were purposefully recruited, so the results may be skewed to those with prior understanding of typical fairness challenges. However, our gaps suggest that the learning curve may actually be much steeper for an average practitioner with more limited exposure to fairness metrics. Toolkits also focus on the model build and evaluation process and largely overlook the remaining model lifecycle, such as checking whether the dataset is representative and analysis of what features are driving the unfairness. Many pointed out non-technical mitigation strategies are not covered in these toolkits. Several were skeptical of debiasing implementations. One interviewee noted that some methods could be inconsistent with anti-discrimination laws. Interviewees also noted that a lot of additional work would be needed for the toolkits to be applicable to their use cases. It is also important to consider whether these toolkits with necessarily reductionist definitions of fairness are appropriate and beneficial from a societal standpoint. One toolkit guidance warns that the tool is intended as a starting point for a wider discussion. The practitioners were generally positive in their reaction to the notion of a fairness toolkit to help navigate an extremely complex issue. But several expressed concern for fairness gerrymandering or fairness washing, falsely portraying models as fair based on incomplete information. Here's our summary of the wider implications. Despite these toolkits, industry practitioners are still struggling with finding a way to identify and mitigate potential unfairness in their models. An effective fairness toolkit could foster the culture among practitioners to consider and assess unfair outcomes. But a poorly framed or designed toolkit could engender false confidence in flawed algorithms. We should critically examine the role of general toolkits to address such a complex socio-technical issue. Future toolkit development should remain vigilant to ensure their adoption is aligned to the overarching goal, to ensure our algorithms reflect our ethical values of non-discrimination and fairness. Thank you, and please reach out with any questions or comments.